All right, well, we're just going to go ahead and get started. We got quite a bit to cover today, but this is going to be a special presentation. So we'll just go ahead and move right into it. So we're going to have a couple presenters today. I'm Josh McBride. You've heard from me a few times before. We're also going to have Nathan Eliason. He's also a technical solution specialist. I'll let him introduce himself here in a minute. We've talked a little bit before about who all is involved in this and viewing it and so forth. We're actually going to get to hear from one of the viewers today, or at least an example regarding one of the viewers today. So just a quick overview. We're going to go through some introductions. We'll have a poll. It'll be hopefully a bit of an entertaining poll today. We're going to have about a 30-minute presentation. Kind of the idea we're going to be looking at is the digital key to opening the box. And you'll understand what that is here in just a minute. And then we'll have a customer success story that Nathan's going to share. It's a really impressive story. I'm excited to hear it. More about it. I've only had a little bit of an overview, so I'm excited too. We'll have a prize for those that stick around, and then opportunity for Q&A. So a quick introduction. I'm a technical solutions specialist with KETIV. We got 20 years in manufacturing and engineering. You've heard a lot about my previous experience. So little fun fact about myself, I like to throw myself out of airplanes with wings. So that's actually me flying on my back there. That's what I like to do every other weekend for fun. So we'll let Nathan introduce himself.
Yeah, so my name is Nathan Elias, and I'm also a technical solutions specialist. I've been doing this for about 15 years now and absolutely love doing this. I'm not as crazy and as exciting as Josh. I don't jump out of any airplanes. But in high school, I actually did take flying lessons, and I was hoping to become a pilot. But then, of course, my dreams changed as I got older. But it was actually a lot of fun flying, and it's definitely something that I hope to go back and do again someday as I get older.
All right, so how to win stuff. You do have to be a part of the Zoom presentation to win, and you have to be present to win as well. So if you are viewing on YouTube, hop on over to Zoom so you have that opportunity in order to get. We're going to have as we have so far, a $70 prize, which will consist of a book and a gift card. So we'll have our poll come up here in just a minute. And we'll give you a little bit of time to answer this. So take your time. I'll give you about a couple minutes so we'll just move on in our presentation. But I want you to try and think of how many things that you can come up with that you can do with the paperclip. Okay, this may seem random, but I think you'll see the point here in just a second as we move forward. Let me move to the next slide. Okay, so last time we kind of defined what digital manufacturing was, that it's the digital virtualization of data, processes, and analysis. The key being the use of data, making it accessible and using it to make better decisions. We talked about enabling our highly skilled workforce. We know everybody's really struggles with finding new and skilled employees. And we looked at three main areas. Once again, data, simulation, and automation. Okay, so if everybody can throw their answers in here. Okay, so yeah, we've got, most we're getting about 5 to 10, maybe 15. A few got more than 15. So where this comes from is in 1968, George Land with Beth Jarman conducted a research study to test the creativity of 1,600 children. And what he did is he gave them this question. Basically, how many things can you do with a paperclip? That was it. And the idea was to look at divergent or creative thinking. They ultimately came up with over 200. I forget what the time period was. It was more than 30 seconds, obviously. But they came up with over 200 things they could do with the paperclip. But what they found is they would continue to test them. And as they got older, they could come up with fewer and fewer things. So the question is, why do we lose this ability over time? What is happening? And how can we get out of that? So the point is we create boxes, right? This whole idea of thinking outside of the box, right? Well, the reality is all too often we're the one creating the very boxes in which we exist. And the reality is they don't exist. They're just in our mind, right? So with the example of the paperclip, people will, and I've done this with groups and actually had them try to come up with things. And they come up with things like, well, it has to be something that you can actually do with a paperclip. You can't bend it because then it's not a paperclip anymore. It has to be something that somebody would, actually, a marketable idea that somebody has to use, be able to use it in that way specifically. But none of those were rules that were put out. The only question was, what can you do with a paperclip? None of these were rules. So yeah, the paperclip could be a skateboard. Well, you can't really stand on it. Well, I can pretend it's a skateboard. I could pretend that it's a surfboard or a rocket, even something real. Well, I could bend it and I could make it an axle for, a toy car. I could use it for a antenna. And once again, people would come back and go, well, but I mean, you can't really, because it's not going to be the right length and it's not going to project the right frequency. Well, it will work as an antenna. It's just not the best use, right? And so once again, the point is we create these rules in which there are none, and we do it without even realizing it, right? Thus the reason we have such a hard time coming up with so many things to do with a little piece of metal, right? So how do we get out of that? Well, there was a study in which 40 digital transformations were overviewed, and it was found that the companies that focused on culture were 5 times more likely to achieve breakthrough performance than companies that neglected culture. And we're going to come back to this study, but one of the first things that they identified was they got outside of themselves. Okay. And that can mean, okay, if whatever your department is, getting outside of that department and connecting with departments outside of you. That can be research, right? We've talked about before the web of and mass amounts of data, but there's also the internal data that we need to be collecting and utilizing, getting with consultants. And then something we're going to do today, connecting with other manufacturers in other industries, in fact, seeing what they are doing so that sometimes we don't even realize the box that we're in just because we've never seen what's possible. And so that's what we're going to do today. And that's going to help us, as we, have seen numerous times before, get into this cycle of efficiency, increasing productivity, which results in the ability to increase our quality, sales, margins, and revenue. So with that, we'll hand it over to Nathan, and he's going to bring us through this example.
Awesome. Thank you, Josh. So today, what I want to focus on is how we can, like Josh was saying, get outside of that box and how we can think differently and do that in the context of digital transformation, which is this big concept that it's very gaining a lot of popularity. There are a lot of courses that you can take from different colleges and universities out there. I took one myself and it was fantastic. So really, this is kind of where we're heading in the future. Now, I think it's important, and by the way, I gave this presentation about a year ago, the beginning of this presentation, but I think it's important to quickly do a review of it because I think the thought process and understanding how we evolve is important so that we can keep going and getting better and faster and smarter at what we do. Now, if we think before the PC came around, this is probably pre-80s, pre-1980s, the way that we did business was very manual. We had handwritten documents. Everything was hand drawn. There weren't PCs that you could actually even do AutoCAD or things like that yet. Everything was kept in physical filing cabinets. when we did machining, everything was set up manually, everything was operated manually. And so basically, everything that we did was manual because we didn't have machines that could kind of help us do these things better. Then with the advent of the PC, we started realizing, hey, we can take these analog processes, these paper-based processes, and we can digitize them and put them in a computer. Now, when we did this, a lot of times, we would create forms in our computer that mimicked the forms that we had on paper. Because really what our concept was is, hey, instead of having that paper that I manage, now I can manage everything inside of the computer and everything can be nice and neat there. So we would scan legacy data, we filled forms in on computers. This is when 2D CAD came into being. So, we could actually draw out on a computer how we wanted everything to look. We had network folder storage. Machine setup was still pretty manual, but we started kind of getting into some CNC machining. It kind of gave birth and we started happening there. And then, email started being a main way that we would communicate and that we would focus so that, instead of having to walk papers or ideas over physically, we could actually do it over the computer. Then as we started doing that, they started thinking, well, can't we do this better? And so they started coming up with purpose-built systems, and we call this digitalization. And you can think of like your ERP systems. So if you have Oracle, if you have SAP, if you have Epicor, or any of those other common ERP systems, those are purpose-built tools that are meant to capture data. It's meant to process data. It's meant to help have data in a single location that you can use to make better decisions, that you can use to improve efficiencies. And this was fantastic, right? And then this is when we got into 3D CAD models as well. We started realizing that when you built these 3D CAD models, not only do they make pretty pictures, not only do they let us figure out form, fit, and function, but we can also use them downstream, right? We can use them to help us do machining better, or we can send them to customers so that we get better feedback. There's all kinds of benefits and new doors that were open when we started doing digitalization. And at this point, I'd say, companies have different processes that are probably at various stages of those past three, analog, digitization, and digitalization. But the big thing that companies are now trying to figure out is, okay, now that we have all of these amazing digital tools, how do we transform the way that we work? How do we have these tools work together in a way that can help us be more efficient? How can we improve our customer experience? Because now we have all these tools and we can take data from each of these tools, we can integrate them, we can pass them back and forth. We can send them to tools like business intelligence where we can try to look up trends. We can try to understand our customer a little bit better. And the whole concept of this digital transformation is to innovate new ways of doing business. Now even artificial intelligence technologies are becoming more commonplace, and they're becoming to where instead of having to have special access, almost any company can access different types of AI technologies. So there's a lot being done where now we can take all of these digital tools that have been created and we can hook them up in a way that they're smarter and that they work better together. Now, I went ahead and diagrammed out kind of the evolution of this. And you can think of this as kind of like a digital transformation maturity matrix, right? So here on the left is when your analog, again, documents are handwritten, approvals are manually gathered. You literally walk papers around to gather signatures, physical filing cabinets. Then, you move up to digitization, which is where, now things are based in computers. We use email-based processes. We have great spreadsheets. We see spreadsheets all over the place. That happens a lot, even still today. And then you move up to digitalization, which is now you have purpose-built tools that can be a lot more intelligent in the way it gathers, processes, and outputs data. And then finally, at the top end here, digital transformation, where you have automation. You can do things really, really fast for your customers. You can give them superior customer service that you weren't able to before. It's really thinking outside of the box. It's like Josh was saying. Digital transformation is about thinking, how would I do this in an ideal world? Forget about constraints, but how would I do this if I could do it in an ideal way? And so what I want to do is kind of walk you through that with an example today. But before we get to the example, we're going to kind of set the table, if you will, to kind of understand some common problems and themes that I see as I've spoken with hundreds of manufacturers over the past decade. Now, one little thing I want to point out that the way this is broken out, this green here really is about data and process management. This darker blue is about design and engineering, and the bottom is about manufacturing. Now, these are all very important, and you want them all to work together in a way that, again, you can make everything work better for your customers, and you can use data better and all that. But today, we're going to focus primarily really in this design and engineering phase, as we're going to talk about an example of some work that we've done for Hannibal and how we've helped them transform some of their processes. And if you notice, I use that word transform, and that's what digital transformation is about. It's about transforming and changing the way you do business so that you can improve the overall product, you can improve the interactions with customers and so forth. Now, before we begin, again, I want to be really clear what digital transformation is. Deploying digital technology that's customer-centric, it empowers, enables employees, it improves decision-making, it increases process efficiency, and the most important piece of this is that it's centered around data. And digital transformation, it's all about data. It's about having intelligent data, making the data accessible, making the data available that you can then do kinds of reports and studies on. But really, digital transformation is about how you get data, how you process that data, and how you output that data. So the example that I want to talk about how we can, think outside the box and how we can rethink how we do things. I want to take a traditional problem that, I've talked to hundreds of manufacturers that all kind of have this conundrum, at least those manufacturers that are in the engineer to order business. When you get a quote from a customer, or I should say when you get a request for a quote from a customer, there's always this decision that has to be made up front. And that is, how much engineering resources do we put into that quote so that we can be confident in our quote, but we don't spend too much time on a quote that we may or may not win. So the classic conundrum has been, hey, on the one side of the spectrum, we could do no or maybe very little engineering. And the nice thing about that is if we do little or no engineering, we don't waste very valuable and expensive resources on bids that aren't won. That's important. We also have quick turnaround time because now we're not waiting for engineers to go off and do designs, which could take anywhere from hours to days to weeks for that to happen. So we can turn around bids really fast. But of course, on the flip side of the coin, now we have higher risk for jobs that are won. Can we stay in budget? I talked to companies where they don't do much engineering up front and their design engineers say, yeah, we just completely ignore what they do on the bid side because it's wrong, it's not even close, and we have to end up redoing everything anyway. Sometimes that's a risk that happens when you choose to be on this end of that spectrum. And going along with what I just said, it often also requires a lot more work to be done by the engineers on the post-sale side because not much real effort was put in front to make sure that something was engineered right for that specific customer needs. Now, on the other end of the spectrum, you could do an entire full design before you send it out to the customer. The nice thing, on the downside, you could waste considerable valuable resources and engineering hours on bids that aren't even won. So that's a potential pitfall. Also, you are going to drastically increase the lead time it takes to get that quote out to the customer. Customers, especially in today's world, we don't like to wait, right? We want it now. And so the longer you wait, the less chance you have of winning their business. But on the flip side of that coin, the positives is that you have a very high degree of confidence in the accuracy of the bid. It's going to be very accurate. You're going to be very close to the right costing and the right information that you give to the customer. And then on the other upside, once you win that bid, a lot of engineering work has probably been done, and it's a lot less effort to take it from, getting a purchase order from a customer to having your drawing package complete and out to the shop floor so that they can do fabrication. Now, the real give and take that manufacturers deal with is, on this spectrum, if you will, do we want to value speed over accuracy and focus less on having really detailed designs and, more focus on getting it done fast? Or do we value accuracy more? And so, we're willing to potentially lose some engineering hours in a bid that we might not win, but we want to make sure that it's accurate and that we give our customers good information when we send that out to bid. So this is basically the conundrum that they go through. So to look at how we can, so let's ask a question. What if we could have both, right? What if we could develop designs extremely fast that were also extremely accurate? By traditional methods, that kind of contradicts each other, right? You have to choose one or the other. It's kind of this choice that you have to make. But what if we didn't have to make a choice? And what if we could have both? Is there a way that we could accomplish that? So to do that, to think outside the box, we need to first diagram workflows. And by the way, I diagram workflows all the time because you need to see how it works so that then you can understand how you can potentially move boxes around and how you could potentially change things. So in a traditional sales workflow, and by the way, I'd say of the hundreds of manufacturers I've talked to, 80 to 90% have some variation of these two workflows. The tools might be different. They might change the order of it around a little bit. It might skip a few boxes, but by and large, I'd say 80 to 90% of companies I talk to follow this process in some form or other. Up front, you have to go out and talk to customers. You have to gather their requirements, right? So that's really the first very important step. Then we find that a lot of companies, they build spreadsheets. They might build other types of tools that can process data. There's some type of tools typically that companies build so that they can more quickly process these inputs that they get from their customers. Now, typically this, you can't really cost something out if you don't understand what the bill of material is. So generally, somewhere in that process, you have to create a bill of material that you have some degree of confidence in. Then they'll typically create an elevation view, maybe a general assembly drawing that gives a high-level overview of dimensions from a top-level perspective so that they can understand how is this going to fit in my system? How am I going to put this in my warehouse, in my factory? Some companies skip that altogether. They don't even include any type drawing data, which is fine. But sometimes that's a step, sometimes it's not. And then, of course, the final step in the bid preparation is calculating cost and generating the quote. Now, once that goes out to their customers and their customers decide, hey, I want to place this order, they send a purchase order, then we begin what I would call the post-sales process. And this is where, first the bid is reviewed, the requirements are reviewed, then the engineers go out and they do their work. Sometimes this is one engineering team. Sometimes you might have, electric specialists, you might have piping and instrumentation specialists, you might have manufacturing specialists that all work together in conjunction to actually build out the designs and the models. Then once you create the design, assembly drawings are created. Oftentimes those assembly drawings are approved by the customer so that you can make sure that you have their buy-off and approval before you create all of the fabrication prints that are required to manufacture and build the product. And then, of course, that last step is, at least from a design perspective, is to create that fabrication package that is then going to go out to the shop floor and is going to be used to build all the components and put together the final product. So if we think outside the box, what we want to think is, well, what if we could do this detailed design up front in the process, right? What if we could create production level models, design work, drawings up front so that we don't have to do it on the back end? That way we know that the design is accurate and we can provide the customer all kinds of great information. Now, if we could do that, what a process might look like is something like this. where now we gather customer requirements. Obviously, like I said, that's a first step you have to do. There's no getting around that. But then from there, we would directly create our designs from the information that we gathered from the customer. We could create assembly drawings. And right here, we could actually get the customer sign off if we wanted to, even on the pre-sales stage. The nice thing is typically if we use 3D CAD systems today, bill of materials automatically come along for the ride because we know how the product structure is set up. We know what it's taken to build it. And then from there, we can calculate cost and generate quotes. Now, wouldn't that be nice, right? If we could do all of that on the pre-sale side, and if we could do it fast. If we could do that, then on the post-sale side, we would just have to make sure that the customer didn't change their mind. Of course, that happens all the time where customers change their mind, and that's okay. But at that point, it would be, going back to the customer saying, are you sure this is what you want? If they have changes, go through the changes, reprocess the changes that they want. And then once we do that, then we can quickly create the fabrication drawings and then release it to production. Now, you might ask, well, how is something like that possible, right? Again, this is thinking outside of the box. Well, we can't do it that way today. How would we even make that possible? And the answer of how you make a process like this possible is through design automation. And typically when we build these design automation solutions that help us streamline these sales and production workflows, we gather customer requirements through some type of dialogue, right? We have some kind of questionnaire that either salespeople or engineers go through and they answer all these questions. And as they answer all of these different questions, then we build an engine that knows how to take all that data. It knows how to pull all the right pieces, how to size it, how to place it all together to make designs that are valid and that are right for the specific requirements that customer has. Now, sometimes it's a single dialog box and boom, the product is done and it's ready to go. Other times, which is in the case of Hannibal, where the systems are a lot more complex, we have a lot of different dialogues depending on what the customer wants. And then after we answer all the questions to these dialogues, we know how to put everything together to quickly create, the final design that a customer wants. Once we have that model, then we can actually very quickly automate outputs. If that's a drawing, we can quickly automate drawings. We can also automate quotes, which is exactly what we did for Hannibal. And I'm going to start going to that in just a minute and show you what we did for them. And so now what we've done is we've taken a traditional problem where you had to choose, do I want either speed or do I want accuracy? And we've turned that into, now I can have both. And again, so thinking outside the box, stop thinking of these traditional, these traditional boxes we paint ourselves into and these traditional limitations that we think we have, and start thinking, how can we do this? And I'll tell you, even sometimes if you come up with something that's not possible with today's technology, chances are 5 years from now, it will be possible. I mean, the way that technology is progressing today, things are improving very fast. AI engines can almost do design work at this point. So, I mean, we're getting to a point to where there's a lot of power out there, and there's a lot of ways that we can improve our workflows. Now, like most companies that do engineer to order, Hannibal had several different challenges that they were confronting. The way that they did it was that manual, traditional way that I showed that, I see over and over again all over the place. And because it was manual, it was error prone, and it was also time consuming, right? Because now every engineer has to go through and think, okay, how does this decision affect, how we build our racking system? How does it affect how we lay out the warehouse and how all of these go together? Sometimes they would also create elevation views, and they would include that in their quotes. But sometimes, your customers, when they see your 2D drawings, they might not understand it. You do, right? Because you work with this day in and day out, and exactly, you can look at a 2D drawing and you know exactly what you're looking at. But from a customer perspective, they don't have that same experience and background you have. So they may not know what they're looking at. And because of that, later on in the process, when they get an order or they get more information, they might say, well, that's not what I thought I was asking for. And so that might require change orders late in the process. Or even in worst case, it might require a job to have to be redone and, scrap to have to go out to this, and scrap obviously can be expensive. In addition to that, because the process was so slow, they have a good engineering team, but they're always overloaded with jobs that have to be done because each one just, it takes a long time to process and you have to go through your queue. Also BOM calculation, to calculate that bill of material and to figure out, all the different beams they would need and the different hardware and the brackets and all that. That was a tedious and error-prone job. And that took, potentially hours for them on big jobs to go through and just calculate that. And when you get big jobs, I bet you if you counted twice, you probably wouldn't get the same answer. If you counted 10 times, you probably wouldn't get the same answer twice, right? Because things can become really complex when your jobs get really big. And then finally, when you have to get new engineers, and by the way, I'm sure you've all heard of the Great Resignation, right? That's one of those things that you read all over LinkedIn and the news, wherever you go today, that engineers and professionals and people in all industries are leaving their jobs and finding new jobs. And so now it's more important than ever to think, well, how do we onboard our new people, right? I remember before I became an engineer, I heard that most companies don't expect new employees to become really productive until 6 to 12 months after they start a new job. Well, is there a way that we can shorten that so that when we have to hire new engineers, it doesn't take 6 to 12 months for them to produce good, valid work? Can we make it so that maybe after a couple of weeks, they have all the training that they need and the tools that they need that they can be productive right out of the gate? And again, digital transformation is about making it your internal processes better so that you can take care of your customer in a much better way. So what we did, to come up with a solution, we went on site and we visited with their engineering team and their sales team and some other teams internally to kind of understand how does this process work. We diagrammed it out similar to what I showed earlier in a more general sense. And what we did is we reviewed that process with them. Then we reviewed, well, what inputs are required to design and engineer a system? Because it's important for us to understand, what are the information that's important to you? And then just as important as all of those inputs, how are they used to determine what type of system that you would design for your end customer? Now, once we understood all of that and we understood, okay, this is where they're starting from and this is where they need to go, then what we were able to do is design and architect a solution that helped them drastically decrease the amount of time it took for them to create a design. Now, what we ended up building, so inside of our 3D tool Inventor, we built a suite of tools that have very specific functionality and tools that it has their specific rules, their specific processes built into our system. So before, what might have taken hours to do inside of AutoCAD, or even if you knew Inventor and you try to build this on your own, you can tell this would minimally take hours if you were extremely experienced and knew what you were doing, maybe even days to build this type of a system. We're able to take that and give them a suite of tools where now they could build this in 10 minutes, right? And that's what digital transformation, that's what design automation, that's what all of these tools are about. It's taking processes that before took months, weeks, or days, and cutting them down to days, hours, or even minutes to get it done. And when we showed them the first prototype of how this worked, they were just blown away by how quick even a new engineer that might not know all of their rules, they didn't have to know every rule and every detail. Because if they could come in and follow the guided dialog boxes throughout the tool, all they had to know is how to go in and fill in all of that information, and the system would automatically process all those rules and build valid designs every single time. So basically we have this tool that has all these different commands to help them build the assemblies. Once they build the assemblies, we have tools that can help them build drawings, can build bill of materials, can build quotes. So it's not just about creating a pretty picture. It's about creating data that is very rich in information, and then taking that data-rich information and repurposing it based on what you need, whether that be a quote, a drawing, a bill of material, all different kinds of things that we can do with it once we have that data. But the key is if we don't have this data, there's not much that we can do with it. And that's why digital transformation is all about putting in systems, putting processes in place where you can get rich, great data about your customers, your products, whatever you're doing. And then you can use that data to improve all of the different processes that your company goes through. So what were the benefits from this? Well, I already mentioned, there was a significant reduction in the amount of time that was required to generate a quote. Not only that, but the quotes were more accurate because computers can count really fast, and computers will always get the same answer whether you do it one time or 100 times because it knows exactly how to count, and it counts the same way every single time. There's also consistency between quotes. Now that it was generated by a computer, it's always the same no matter what customer you do, no matter how they configure it. The quotes always come out very similar in a very good fashion. It also allowed them to communicate better with their customers. Like I mentioned before, customers can't look at a 2D drawing of a rack and immediately know, oh, I get it. I understand what you're telling me that you want to deliver. But on the other hand, if you can, give them a web link to an online 3D model that doesn't require them to install any software, that they can just click a link and open it and take a look at it. They can mark it up. They can say, wait a minute, I thought this was supposed to be higher, or I thought that this was supposed to be wider. They could put that kind of comments right here. And so now it improves the way that you can communicate with your customer. And not only that, but you can catch problems much earlier in the process, which means that you can save a lot of money in scrap and change orders, all kinds of potential issues that you might run into down the road. There's also shorter time required to ramp up new engineers, and all engineering design work gets done before the quotes go out. Now, as I mentioned, creating this kind of powerful, rich data, it's wonderful in and of itself. But once you create that data, it opens up a whole new set of possibilities that before you create such a system, you may not have even had. And so now they're looking at, potential things they can look into is, well, how can we improve the way that we send the information to manufacturing? Now that we have 3D models, we can get cut lengths, we can get drilled holes, we get all that information. We can probably just send it out to a machine and have a machine do it automatically. We don't have to worry about, setting it up each time. Now we can run in-house product simulations because we have a 3D model where we can add loads to it. We can understand how this will deform under certain types of load conditions. We can integrate this data to other systems if we want to send bill of materials directly to ERP systems or other type of business systems. Now we have the ability to do that because we have the data in place that we need first before we can make those integrations happen. They can also provide models for building mockups. They serve companies that make these huge warehouses where they have to put all kinds of racking systems in there. And so imagine being able to give their customers a lightweight model that then they can use to lay out inside of their warehouse. And then, of course, if you can give it to a company to lay it out in a 3D warehouse, now you're just a quick step away from being able to provide an entire virtual reality experience. Again, how can you improve the way that you communicate with your customer? How can you improve the way that you serve your customer? And so we can see that by thinking out of the box, we're now able to have both speed and accuracy and get all kinds of other benefits by doing design automation and thinking of the entire process as a whole. So I appreciate you guys staying with me on this presentation. Hopefully you found it useful. And at this point, I'm going to go ahead and turn the time back over to Josh.
Thanks, Nathan. That was really, really awesome, especially to see a company going through that transformation and all the possibilities that are attached to it. As you mentioned, they're still going through this transformation, finding other ways they can utilize that data to improve their processes. So kind of getting back to the whole digital transformation, looking at data, the question is, where can all these ideas be applied, right? Well, the reality is ultimately they can apply anywhere in your business. It doesn't matter if we're talking about the shop floor or with an ERP system. We can connect to that. We can, you can advance the slides real quick, Nathan.
Oh, sorry.
Yeah, no problem. Whether you're talking about engineering or even quality, right? They collect a lot of information that can feed all of these systems as well. So, I know most here are engineers, so, you're familiar with these particular areas, but, keep in mind that you have data, or can and probably should have data coming in from so many other areas as well, whether it's quality, purchasing in the ERP systems, whether it's CRM systems from sales. All of these are pieces of information that we can utilize and connect to. So our next session is going to be next month on April 13th. That next section, we're going to talk about other types of improvement initiatives, such as lean manufacturing, Six Sigma, green manufacturing, all these different buzzwords that you've probably heard and maybe have some training in. I've got certification in a number of those. So how do they fit in with digital manufacturing? That's what we're going to talk about next time. Of course, if you have any additional curiosities or questions, you can always contact us, and we can have a one-on-one session to discuss and identify opportunities. And then, of course, we're always open for suggestions on other topics to discuss. So we're going to have our winner real quick, and then we'll get into our Q&A. So our winner for today is Amir Shayan. If you can just reach out to us, I'll put, you can reach out to marketing@ketiv.com, and we'll get that into the chat there for you as well. So our winner is Amir Shayan. Okay. And once again, we'll have other opportunity next week for a winner as well. Other opportunities to learn, we have the KETIV Virtual Academy. That's mainly for users. And we go into particular products and how things can and can be utilized and done specifically within software. And so Q&A, we've already got a question here from Rodney Culler. Let's see, can we generate a spreadsheet questionnaire that we could give to our sales and take that and plug it into a design model for pulling that data to generate the model and drawings? So I'll give a quick answer, and I'll let Nathan answer as well. So ultimately, yeah, you can create questionnaires. I would suggest against using specifically a spreadsheet. There are multiple ways that data can be pushed and pulled. One thing that I mentioned in our last week's session, we'll be covering tomorrow in our KVA, which is a piece of software called Tacton that can automate design in Inventor. And it provides a user interface that can be utilized by your internal sales force, external sales reps, or even customers, depending on what you want, in order to take that information, provide the questions, crunch it, give live feedback on those questions, because depending on an answer to one, you might need a different question as your second, right? Or the possibilities to those answers may shift and change, things like that. And there's other ways to go about that as well, with whether that's, VBA and API and other methods as well. And I'll let Nathan give his thoughts.
Yeah, no, I definitely echo Josh's comments. There are other ways that it can be done. I mean, can you do it that way? Absolutely, right? I mean, you can create a spreadsheet that you have your salespeople fill in different types of information. And then in your CAD system, you can set it up so that it pulls the right information from the right place. It updates, different parameters. It rebuilds models. So all of that can be done. But I do want to be clear that there's a lot of ways that you can do automation. Some paths, if you choose, are going to make data management a complete nightmare down the road. other ways work much better. So yes, you can do it that way, but I would recommend at least having us look at it for you to give you some pointers, because like I said, automation is wonderful, but if you do it in a way that makes the downstream processes is more difficult, then sometimes you create some problems that you don't intend to. And so it's just good to avoid those as much as possible.
So another question here, and there was one earlier by Rodney that I think is along similar lines. I wasn't quite understanding it, but this one is also from Jared. And it says, in terms of design automation, would you consider VBA to still be a viable option with an Inventor? I'll let you go start on that, Nathan.
That's a good question. You know, the funny thing is, I remember back in the year 2000, I was using VBA, and Microsoft said, hey, this is going to go away, right? And they said it's going to be sunset. And here we are 20 plus years later, and VBA is still around. So is it ever going to be really gone? I don't know. But personally, I would recommend, especially if you're getting started, I wouldn't start with VBA. Especially if you're inside of Inventor, you can use iLogic, which is, you know, much better. It still uses Visual Basic, which is good. So it's easy to learn if you already know how to do VBA, and it opens up a lot more doors. It's has a lot more possibilities. So I guess the short answer is you could still use VBA today, but just understand that it's a technology that Microsoft thought they were going to obsolete 20 years ago. Yes, it's still around, and the reality is it's probably still going to be around 20 years from now, but it's not really actively developed by Microsoft or anyone at this point. So I would personally, if it were my choice, I would want to use technologies that are more up to date, that you know are going to have a much longer lifespan.
Yeah, and along that too, the other consideration is that the best approach for what you're trying to achieve, right? So the example we saw today, they used a API, and that was really due to the situation that they were facing. When you're dealing with such a highly variable, highly customizable, and the key is customizable versus configurable, a highly customizable situation, then you need a certain level of flexibility that API can provide. When you're dealing with a configurable product, and this will really get defined in tomorrow's presentation, because a lot of people crisscross configurable and customizable, okay? But when you're dealing with a configurable product, okay, there are solutions out there that dramatically reduce the amount of programming, really to the point in which you're not programming at all. You don't have to do any programming. You don't have to understand the language or anything. So your low-level drafter could really automate within Inventor and do it quickly. And it provides something that can be built on and is future-proof, that can ultimately lead to augmented reality in the future, versus kind of painting yourself into a corner, relying 100% on a programmer in a situation where that may not be the best approach. So that's something else to consider, is what is the long-term goal? What is the product? And is that really the best approach for it as well? Okay, well, I think that covers it for today. We're pretty much out of time. Of course, once again, we're always here and available for anybody that has some additional questions, wants to dig in, what is the best approach going forward, so that you're set in a good place for the future. We'd love to discuss that and help you with that. Thank you all for your time, and hope you have a wonderful rest of your day.